then 1, then 2, then 3.
Okay.
And then the y values are 10, 12, 14, 16, 18.
Like this.
Yeah.
Okay. This looks very linear, not very quadratic.
Yeah. So it said determine whether it's linear or not, then write the function. If it's quadratic, put it in standard form. So you
Okay.
put this in vertex form, right?
Well, this is linear. So, and I know that from looking at it, but here's how you can know. You take what's called the first difference. So the first difference is 12 minus 10. So you take that next term and subtract the previous term,
Mm-hmm.
and that equals 2. And then you do it again, 14 minus 12, 16 minus 14. And if these are all the same, okay, then it is linear.
Okay.
Okay, and for quadratics are the second difference, which we'll do, maybe next. So this is just the equation of the line. Y equals mx plus b is probably your best choice here because you need the slope. And the slope is what it's going up by each time. And then the b value is the y-intercept.
Okay.
So y equals,
Oh, so we would just write it in slope intercept form. That's it.
yeah, that's it for this one, because this is not a quadratic. I mean, I don't even think this would be on your test, in my opinion, but I don't make your tests. So,
Okay.
okay. So next question here, if you want to read it off. I assume it's a table again.
Yep. So this one is x is -2, -1, 0, 1, and 2. And then for the y values, it is 4, 2, 1, 0.5, and 0.25. I
Like
think that's
this.
quadratic because it's divided by 2 every time. And yeah, I like that.
Okay. So again, like the way to do it is the first difference and the second difference.
Okay.
This one is actually not quadratic or linear, but I'll show you here. So it's 2 minus 4, that's -2. 1 minus 2 is -1. 0.5 minus 1 is minus 0.5.
Yeah.
And then 0.25 is minus 0.5 is minus 0.25. Okay. So if you take the second difference, and this is as far as you'd want to go, it's -1 minus a -2. So you're doing the next minus the previous. And that's 1 minus 0.5 minus a -1, which is 0.5. And then minus 0.25 minus a -0.5 is 0.25. And again, there's no pattern. Okay.
Yeah. So it would be quadratic.
No. If you're for quadratic, the second difference has to be the same.
Oh, so it's it's exponential.
It's exponential. Yes.
Is it it's not a square root function.
So it's pat. I don't know if they still call it that, but pat is the exponential, and your a is the ratio of your next divided by your previous. Basically, it's like what is happening to go in this direction, and divided by 2, divided by 2. Hopefully you can see that. But
So then how would you write an equation like that?
well, so you don't use division. It's times 1/2 instead of division by 2.
So f of x equals 1/2.
No, close. So f of x equals the first term and then the 1/2 to the value of x. So you've got to give it that starting value when x is 0.
So when x, so then f of x equals
It's
parentheses 1/2
yes,
times
yes.
to the power to the square. So it's to the square root of 2.
Power 1/2 to the
Of,
power of x.
oh, it'd just be to the power of x.
Yes.
Okay.
I mean, this is different than stuff we've been covering, but it's all related.
Yeah.
Again, those emails have not come in. Maybe check to see if you got a return error message. I don't know if mom can text me pictures real quick or something. It will help if I can pull up the
Yeah.
problems rather than doing it this way. But
Let me see if I can like attach maybe if I like, open this as a because she posted it on like Google Classroom. I'm
Okay.
wondering if I open it in
I
like a
can
Google Docs.
also let you share your screen and snip some questions, or if you can download as a PDF from the Google Docs, that's also an option. Drop it in the chat.
Oh, how do I do that?
You
Oh,
can, in the chat, you can always just drag and drop files
oh, okay.
from your file
Uh,
system.
that there. Chat. Oh, I could take a screenshot.
Yep.
Okay. So then I'll probably do that. Screenshot. Uh, all that. Capture. I didn't know I could do that. Okay. So now is it showing up? Did that one like come through?
Sorry. Yes, that's good. I was muted. 11 now. Is that
Yeah, 11.
okay? Yeah. And if you want to keep dropping in screenshots, you can do
Yep,
that.
that was it.
Okay. All right. So we need to do a first difference here. So again, it's going to be -5 minus a -4.
And I can
That's
already tell because it goes from -4 to -1 to 4 that it won't be a difference because there's no pattern.
well, you'd really want to plot them. I mean, that's the other way to do it. That's where I wasn't sure how you guys are doing it in class. Like if you were to plot this -1 -4, 0 -5, 1 4
It's a
minus,
parabola.
yeah, and I'm going to show you this with the first difference as well. But you're supposed to do these differences. So this is -1, and then it's -4 minus a -5, which is +1, and then it's -1 minus a -4, which is 3, and then 4 minus a -1, which is 5. And you might say, oh, well, there's no pattern there, and you're right. But if you do the second difference, okay, 1 minus a -1 is 2, 3 minus 1 is 2, 5 minus 3 is 2, and wouldn't you know it, those are all the same, and that's why it's quadratic.
Okay.
Did you see these first differences in class, or did they do it
No.
okay. You guys were probably plotting them then.
I don't think we haven't really done this. I think that the expectation was if it was divided by, it was exponential. There was like if it was clearly linear, then it was linear, and if it was anything else, it had to be quadratic.
Okay. I would make a quick sketch, and one of the things you might notice is if is a duplication of values. That's sometimes a good indicator that like it
Okay.
was, you know, bigger and rough, really rough. So like 5 minus 1, 0, 3. I'm sorry, this is terrible. This is completely wrong. Sorry, the order -1, 5, 0, 3, 1, 5, 2, 11. You can see that it's got
Yeah,
this.
it's a quadratic.
Yes. Okay.
So
And
then
if that's all you got to do, then that's all you know.
so then I'd have to write an equation for this one. So I would start in vertex form and then convert that to standard form.
Oh, I'm sorry. So you actually have to write the equations here
Only for 12.
for 12. Well, 11 was quadratic.
Okay.
So we should do that
Oh,
for
okay.
11. Let's do 12 and we'll come back because I
Okay.
messed this up bad. All right. Yeah. So you said in,
So you start in vertex form because that's what it gives you, and then convert to standard form.
yeah, I think that's the right. I would do that. So
Equals a x minus h squared plus k.
so you have to recognize where your vertex is, which is 0, 3,
Yep.
HK.
Yep. So then it'd be y equals a x squared plus 3.
Minus 0, yeah.
But yeah, but it would just be x.
AX squared plus 3. And then you can use any other point, and I would stick to the positives. rather than
Yep.
negatives. So like 5 equals a times 1 squared plus 3.
So then a equals 3. So 2 equals 3a. Or sorry, 2 equals a. Yeah.
Yeah, and then you have it here. Now, this just happened to kind of work out to be in standard form. You would normally want to expand the binomial. So we probably will see that in 11 when
I won't. So then you
this,
plug a 2 back into a and multiply out, right? To get to standard form.
yes, yes.
So then y equals 2x minus 0
Oh, no, no, no.
squared plus 3.
Well, you just said that the x squared is x minus 0 is x squared. Like you don't, this is
Oh,
okay.
so it would just be 2x squared plus 3.
Yeah. This is
Okay.
missing the middle term, but for
Oh, because it's x minus 0.
yeah. So 11 will be more, this is more of your test question here. So again, there's your H and K. Actually, I take that back. This one doesn't not much different. But we've got x minus 0 squared minus 5.
Is it because is it because the vertex? Oh, this isn't. How do we know that that's the vertex? Because that's a
It's
y-intercept.
it's kind of this place where it comes like if when we graphed it.
Oh, because it's the max or the min. So
I
the
mean,
highest or lowest number.
like in full disclosure, it doesn't have to be, but that's what they're trying to show you. Like,
But
yes,
usually
yes,
it will be.
yes, yes, yes.
So it doesn't always have to be a y-intercept
No,
or
and
an x-intercept.
you shouldn't expect it to be the y-intercept. I mean, that's
Okay.
just a nice, that it's being nice,
Yeah.
friendly here.
Okay.
Okay. So yeah, so my recommendation, we use the positive values as much as
Yeah.
possible to find.
-4 equals uh a equals 1.
Yes, a is 1, and that goes back there,
So
and you
then you
get
have x squared minus 5.
yes.
Okay. Not bad.
Okay, so
Okay.
definitely need it. So you've already done like 1, 2, 3, or you don't have any
Yeah,
questions
yeah.
on
No,
those?
I don't have any questions. Those are just
Okay.
graphing, and then even or odd, I'm pretty good at that.
All right, so just if you want to take another snip, or I don't know, maybe you already did drop something in the
Yeah,
chat.
they're all in the chat, every single problem.
Oh, fantastic. Okay. So let
Oh,
me,
wait, I am missing one. So then let me do that really fast. I am missing the bottom half. So the snip I'm about to send is there is the right under the ones we just did,
okay.
13, 14, and 15.
Okay. Okay, see that there. All right, let me grab 13. All right, write a quadratic function standard form whose graph satisfies the given equation.
I like
Uh,
doing these.
yeah, so you have to recognize, like, what are they giving you? What is minus 2,
So
0 and
you
what is
so
3,
you
0?
can you can put this in directly in standard form because it's giving you 2 points on the graph and not just a vertex. Should be like y equals a x minus 2 x plus 3 or
Okay,
x
so
plus 2 x minus 3.
yeah, so they're giving you the x-intercepts.
Yep, and then you'd plug in the vertex for
Well, you want to use factored form here because they're giving you the vertex. I'm sorry, the x-intercepts. So it would look something like this: a,
yeah,
and then
that's what I did. Yeah, y
and the,
equals a x plus q times x. So I don't remember what the variables are, but yeah, that's what
good.
I got.
Okay,
Then you
now,
plug in the vertex, so it'd be
well,
-2.
you don't know that this is the vertex. This is just another point on the graph.
Oh, well,
but you're right. You
you
use
would
it to
just plug
find,
that in.
yes.
Okay. Equals 2 plus 2, 2 minus 3. So -2 equals 4 times -1. So A equals 1/2.
Yes. And that goes back in here, but you're not
Yep.
done. You're
You have
this
to
one,
FOIL it out. So then
and
you'd
then
have
multiply
y
by the one
equals
of,
1/2 x plus 2 x minus 3. So then you'd get
I didn't hear any square. It's x squared, right? Because when you FOIL this, x
oh
times
yeah,
x.
I was just writing down the first. I haven't started
Okay.
FOILing it. So
Okay.
then you get x squared plus 2x minus 3x minus 6. Then y equals 1/2 x squared minus 1/2 x minus 3.
Yep. And that's in standard form.
Yep. I like doing these ones.
All right. So number 14 is similar. It's important again to recognize what they're giving you. And that's why you may want to sketch the
The graph
points
before you do anything.
just to see like, well, okay, they're giving me that one, and there's that one, and there's that one, and then it kind of leads to the same as the previous problem.
Yep.
But so go ahead and give this one a try, and let me know what you come up with for your final answer.
So I'm just confirming I did this right. So then I got for the first like part, what 0 equals 4 times 0 equals a times 4 minus 0 times 4 minus 2.
These are so it would be,
Oh, it
if,
would be,
yeah, you're using these 2 points to write the
oh,
intercepts. Yes.
does it, so it does matter like which order I use them in, or no, it doesn't?
No, I mean you could have done x minus 4, x minus 0, but you have
Okay.
to use the ones that cross the x-axis.
Okay. So then so they have to be x-intercepts, so x minus 0, and then oh, they got sneaky, so they didn't put it in order.
That's right. That's right.
Okay, so then 2 equals a,
So
2
I would
minus
do
0.
I would do a little simplifying here. You know, I would maybe do that next, but you are going to use that other point to find the value of a.
Yep.
Yeah.
So then I got a equals -1/2. Then I gotta plug that back in. Then I got y equals -1/2 x squared plus 2x plus 0.
Okay, so you would not write the 0,
Oh,
but the
you
rest
don't
of
have to.
this, yeah, and it looks bad. It's actually you're the type of student that should know better than to do that. Now you can check your answers, right? Like when x is 0, is y 0 with that first point, and it
Yeah.
is. And
So
then you
you
can check,
plug in 0. Yeah.
and then you can check 2. Is -1/2 times 2 plus 2 times 2 equal to 2? And
Yes.
there is a problem with that one.
Oh, there is. So then negative.
Yes.
Oh.
So there is a mistake here.
Okay. So then x times x is x squared.
So it is -1/2.
Yeah. So I
Some
must have done something wrong foiling it. So then x squared minus 0x minus 4x. Oh, it's a minus 4x. Oh, wait. Plus 0. So then I still got y equals x squared minus 4x, which when you take the negative 1/2, you get y equals negative 1/2 x squared plus 2x.
Yeah, I agree. There's something, maybe that, I'm looking at it too. Let me just do a quick graph of this.
Yeah.
Um, oh, this is squared. That's why. I'm sorry. It is right.
Okay.
Okay. I had the wrong. I didn't have that in there. Yeah, it does work.
Okay.
Okay, very good. So, like you just noticed, you can't just go in order. It's not going to be patterned that way. 15 is leading you towards a certain form. Let me snip that in here. When you see 15, when it gives you the vertex, that's telling you what form to start it out in, which is vertex form. So notice, like, you can start in factored form and go to standard, or you can start in vertex form and go to standard. So this is your H and your K.
Okay. So this is when you would start in vertex form and then go to.
Yes.
Okay. Yeah.
Okay. So again, you know enough to try this one on your own.
Yep.
Please ask me some questions if you have any along the way.
Okay. X minus 0 squared plus 3, then negative 45 equals a minus 4 minus 0 squared plus 3 minus 3 minus 3. And then negative 48 equals 16a. Then a equals negative 3. So then y equals negative 3. X minus 0. Oh, wait, this is so I can just plug this back into the top one. Right, so then you get negative 45 equals a 6 times 16, negative 4 squared plus 3. So then y equals negative 3x squared plus, is it y equals negative 3x squared plus 3?
Okay. So for sure, it works with the first point, right? 0 and then 3.
Yeah.
And then the question is, does it work on the next one? It does. Negative 4 squared is 16. Negative 3 times 16 is negative 48 plus 3 is negative 45. So yeah,
Nice.
it does work. Okay. So check your signs. If you have extra time, check your points, with your graph there. All right. So now just move on to 16. Is that okay? Or
Yeah.
all right. So new grouping of questions, new emphasis here. When it says to find the zeros, okay, the zeros,
Yeah, it's the
that
opposite. So so you have to add, so like you have to put this into uh like the vertex form, like what it would be in vertex form, or the
I, I
first stages of standard form before you FOIL it all out.
I I
Then
think
you
you
can
mean,
find the
if
zeros.
you mean factored form, yes.
Yeah,
Like,
that's what I meant. Yeah,
yeah,
where it has like x minus or x plus
yeah.
something
So
times x,
what is the first type of factoring you're supposed to do?
greatest common factor, which there is.
Yeah,
So you'd factor out -2.
yes. And you're setting this whole thing equal to 0.
Yep.
Okay, so go ahead and factor that. Let me know what you come up with.
Then I can just get rid of the -2 because it will serve no purpose.
It's not part of the solution. That's right.
Yeah. So then has to multiply to -6, but add to 5. Um, Oh, 6 and -1. So then x minus 6 times x plus 1. So the zeros are x equals 6 and x equals -1.
Yeah, if you said x plus 6 and x minus 1, you are correct. X equals -6. And sorry, I'm having a weird issue with my screen. And whoa. Okay, that's really weird. And x equals 1. Is that what you've got?
Yes. I got x equals 6 and x equals -1.
So it your factoring is slightly off,
Oh, yeah,
and that's
yeah. I
that's
just
really
I just wrote the wrong sign in front of the wrong one. So I had it
okay.
right. I just like wrote it
Yeah.
wrong. Yeah.
Now I want to show you something real quick because I want you said something, and I think you're the kind of math student that would actually appreciate what I'm about to show you. Um, okay, so this is the original one, and you agree that those are the two solutions. Is that right?
Yeah.
Okay. Now when you factor it, okay, you're going to get the same solutions. Okay, so that's no different. Okay, but you said something, and this is really important here. If I remove the -2, do you see that it has the same solutions, but it is not the same graph?
Yeah. That's because it reflects over the x-axis. That's what the -2 means.
Right. And the important thing here is to realize that, like, yes, you can disregard the -2, but you're actually solving a different problem when you say I don't need to care about the -2 anymore. Like if you just divide it out, you're changing, you're really changing what you're solving, even though it gives you the same answer. Like
Yep.
you're and it's yeah, it's correct, but just know why it's correct. It's because the reflected one has the same intercepts, but it's not the same function.
Okay.
So that's all I'll say on that there. Okay, moving along. 17 is already in factored form. That's really nice because you don't have to do anything to solve for, you don't have to factor. You've already got it all ready to go here. So what are the two x-intercepts for this one?
Let me figure that out. Then equals um oh wait, this is kind of in factored form, right?
It's already, you just said 3x minus 1 equal to 0 and 2x
Oh,
plus 7 equal to 0. Yeah,
oh
you
yeah.
don't overthink it here.
So then x equals -3/2 and x equals 1/3.
Yes, very good, very good. Okay. Now 18 and 19 are no longer quadratic, but the same,
Principle applies.
yeah, exactly. That's exactly the wording I was thinking is. So this is considered a higher order factoring. Did you get any of these on a last test or quiz?
No.
Okay, so here's the approach that we're gonna use. We're gonna let u equal x squared. So in math, the more math you take, the more you'll see substitutions like this. And if you
Okay.
square both sides,
You'll
u
get
squared,
x to the 4th.
right? So this becomes u squared minus 5u plus 4, right? And
Okay.
you can factor this. So what you've effectively done here is reduced the order of it. There's a technique in differential equations. It's the same thing here, reduction of order, and that's what you've just done here.
Okay.
So you factor this, you get u minus 4, u minus 1, okay, and then you realize, like, but I don't want my answer in terms of u. I want my answer in terms of x. So you back substitute. So you make a substitution, but then you always put it back. X squared minus 4, x squared minus 1. And you're supposed to say to yourself, oh, I know how to factor these. These are, let you fill in the blank on that. What type of factoring do these become?
The so it's like a square root, so you have to take the square root of 1 and the square root of 4.
These are difference of squares.
Yeah. So it'd be x equals 1 and x equals.
Well, you're solving it. We're continuing to factor here.
Oh. So there'd be, oh, so this would this be one of the ones that like goes up and then down and then up and then down?
It does. It goes down, up like that.
Yeah.
It looks like
That's
a
why it has
W.
so many
Yeah,
x-intercepts.
yes. But what I'm trying to get you to see, and I'm not sure if an issue, is that these are both difference of squares. So
Yeah.
you're supposed to know how to factor them
Yeah, I know how to
out.
factor difference of squares.
Okay, and then you set
Okay.
each of these equal to 0, like the whole
Yep.
time. So there's four intercepts.
Okay. So does the exponent of the x have anything to do with how many answers there are? So it's
Yes,
x to the fourth.
that's called the fundamental theorem of algebra.
Okay.
And that's exactly what it is. There are four solutions. Now,
Because there's 4 x's.
yeah, well, it's because it's power of
Which,
4,
yeah.
but this might blow your mind a little bit. They are divided among real and complex or imaginary solutions.
What's the difference?
You'll find out in a bit. So,
Uh,
like, we live in the real number world, like when we interact with people, but there's imaginary numbers
I've
that
heard
are,
of like imaginary numbers.
yeah, and that's what that's so they so the graduate at graduate exams, they sometimes will give you a very complicated problem like this. So they'll say like x to the 10th equals something that you know doesn't even matter, but there are literally 10 solutions to a problem like that,
Okay.
and you have to be able to find them all through complicated methods. But you're right, you're
Okay.
exactly right. That's really intuitive to see. Like, yeah, there's four, 1, 2, 3, 4. Problem is they're not always all real.
But for the purposes we're doing, they will be.
Yes,
Okay. So then for number 19, there would be 3 solutions.
yes.
Okay. Let's see if I can work number 19.
Yeah, so go ahead and work that out, see what you come up with.
So would I do the U thing or not
I
for
believe
this
this
one?
one, I thought this one had a GCF.
Oh
This
yeah,
one,
you can factor out x. So
yes,
then f of
2x,
x
2a,
equals,
2x.
oh yeah, 2x, then x squared minus 9, which is a difference of squares. So x plus 3, x minus 3. So then x equals 3, x equals -3. Those are the zeros.
That sounds right to me. And you can check those if you need, you know, by putting them back in to the original function.
Okay.
But yeah, very important what you just said. Because like here, but here's the thing here. Like there's graphs. Like if we were to graph x cubed plus 1, it only hits the x-axis one time, and that's the real root. But there's two other complex roots that you or imaginary roots that you don't know about, but it is exactly what you just said. So
Okay.
I would ask your teacher more about that and see what they say.
Okay.
The answer might be, you know, wait till next, you know, wait till
Yeah.
Wednesday, and we'll,
Wait till we start actually doing this.
yeah, exactly. All right, consider the graph of the function f. Find the domain, range, and zeros of
Oh,
the
so this
function.
is this is just the same as what we've been doing, just with a graph.
Yes. No function though until part B. So
Yep.
A is kind of the like characteristics of it.
So domain is all real numbers, range is y is less than or equal to 8, and the zeros are 1 and 5.
Yes.
That's stupid. Why would it show you the zeros?
Well, they want you to, you know, use them. So just be careful here that sometimes they want ordered pairs.
Yeah, so 105. So on a test,
Yes.
write
I don't
1050.
well, it should be more clear how to write them. I mean,
Okay.
and you might want to write x equals 1. There's some notation here that isn't correct that I would like to see, but I'm not grading you again. So I just go off of what you've been seeing in class. You know, if
Okay.
it's just 1 and 5, you know, do it. Okay, so standard form. You
Yep.
actually have a choice here. You can use factors or you can use the vertex.
I am definitely using factors.
Okay.
So then 8 equals 3x minus 1, x minus 5. Did I do that? I think I did that right.
So I would do it in pieces here, like you just said, x
Yeah, so I
minus
got
1.
y equals a x minus 1 times x minus 5.
Yeah,
Yeah,
and then you can
okay.
use this point.
Then all you have to do is plug it in.
Yes, yes. Okay, so go ahead and figure that out and see what you come up with for A.
Okay. Plus 2 times -2 is -4. So then a equals -2. Y equals -2, x minus 1 times x minus 5. We have y equals -2, x squared minus x minus 5x plus 5. Y equals -2, x squared minus 6x plus 5. Y equals -2x squared plus 12x minus 10. So I got y equals -2x squared plus 12x minus 10.
Okay,
Yeah, that's what I got.
that sounds pretty good here. So I'm gonna go 3. Uh, okay, that looks good. What part C says to compare the graph of f to the graph of g of x equals x squared. What do you think they're asking for here? There's another word they're really asking for.
Um, there's another word that they're really asking. So
Yeah, you can
the
sum it up.
parent function.
Transformations.
Oh, okay. Um, it moves. So it translates up 8. It's a
So
ref
yeah, so
or
order matters here. Yeah, so
yep.
it is up
So
8.
up reflection over x-axis, and then vertical. So you'd have to use this. So then vertical stretch by a factor of 2.
Okay. You're still missing 1.
Yep. Uh, this it. Oh yeah, it's to the So it's where the axis of symmetry is
Yes.
where you would call it. Is where so it's to the left or translates right 3.
Yes. Yes. So I think they're looking for a list like this.
Probably.
Uh, and I'm big on the order. Maybe your instructor won't be as picky.
Okay.
All right. Just keep going in order here. Is that good?
Um.
Or do you want us
Yep.
to go? Okay.
Nope. That's fine.
Yeah, we're not obviously not gonna get through everything tonight, but
Yep.
we've got
Oh,
another
we still have
lesson.
we have tomorrow, I think,
Yes,
as well.
yes, at 8.
Yep.
Okay, so this one's asking for the vertex
Oh,
and
this is easy. So
yeah,
vertex equals -4, -2,
okay,
and line of symmetry is x equals -2.
-4.
Oh
It's
yeah,
it's the x value. The y value tells you the max or the min.
yeah.
The x value is always the axis of symmetry.
Yep.
All
Could we
right.
do some word problems actually?
Before we do that, we need to look at 23 because
Oh,
it's different.
you have to put it in vertex form first,
Maybe you can use formulas.
but it's going to be harder to do with that.
I I mean
Oh,
it's
wait.
minus b over 2a. I mean it's
Yeah,
not
so it's
impossible.
6 over 1. So x equals 6 and then plug that back in. If you had a
Yes.
calculator, that would be easy.
Are you given a calculator on this?
Yes. Let me plug it in. 0.5 times 6 squared minus 6 times 6 plus 10. I got -8. So 6, -8.
Okay, that sounds reasonable. Okay, so let's do 25. Sounds like you want to close out with
Yeah.
a couple of these word problems. See what
Yep.
we can do. So one of the things that with these word problems that they put a lot of words around and graphically, they're typically asking for a couple of things. They're typically maybe asking you something about the vertex or
Okay.
where it hits the ground. Could you read this and tell me which of those two places they're asking you about?
How many seconds will it take? So that's asking about the X. That's when it's gonna hit the ground. Because
But
like you
is it,
can
are they asking about one or two?
two, because you can kind of think of it like a plane.
Yeah. So in this case, they're asking when y equals 0.
Yeah, what is X equal? So then you would plug in 0 for Y
That's
and
right.
then just solve for X.
Now this is definitely, well, I shouldn't say definitely. It feels like a calculator problem because the numbers are so large.
Yeah.
Um,
So then
so I'll, if you don't have one, I'll do the division for you.
no. So then
784 divided by 16 is 49. So this ends up being 49 equals x minus 7 squared.
you would take the square root, so 7 equals X minus 7, X equals 14.
Yes. Now you got to give units. You'd have to say that
Seconds.
it's, yeah, it's 14 seconds. Okay. Now that's part A, right? How
Yep.
many seconds will it take? What's part B asking for?
What is the maximum height? So then that's when
So
oh, that's just the vertex. So then
so
you
but
already
at what
have
I was going to ask you is at one, are they asking for the X or the Y value when they ask for this?
Y, but you have to figure out X before you figure out Y.
But what form is this in?
That's in vertex. Oh,
So you already know the
784.
one. Yeah. So, and then you want to say 784 feet.
Yeah.
Yeah. So like these problems have a clear sort of, when you make the graph, you sort of know, um, again, so like all this one's slightly different, but it's there's something going on here, like it's going up like that, and they're probably asking about one or two.
Yep. And if it's like a distance problem, X or the X axis is going to represent distance and the Y axis is going to represent height.
Yeah. Yes. Yeah.
Okay.
Now, this one's kind of a creative problem because they're asking how long is the ball in the air, and we're supposed to actually figure out the
So
both
where
x
does it
intercept.
so where does it start and then where does it end? And
Yeah.
then the end minus the start.
Yeah. So you got to find the two. Now this one can be done by hand because you can factor out a -6 from everything.
I didn't know 90 was divisible by 6. Oh, 15.
Yeah, and that because we're running out of time here, I'll just help with the factoring. T minus
Yep.
5, T minus 3.
And then so then you'd have 5 and then 3. So then it's in the air for about 2 seconds.
Yes. And then how high does it go? The
The
shortcut is to
vertex.
recognize as the vertex is right between the two
Yep.
numbers, that
So
T equals
then
4,
yeah,
and putting 4 in
for Y
for
or for
T.
X. Or yeah,
Yeah, which is T in this case.
yeah. Okay. I think that was the end of the review.
Yeah, so in terms of what we can do tomorrow, I'm happy to make up questions like these. I would consider